Hello, welcome back. In today's session, we're gonna learn how to use serial communication. But before that, we will get familiar with how the data is represented in binary. In particular, we will focus at the ASCII code, which is the standard used for communication between the main computer and our Arduino board. And later, I will show you how to print or read data from the serial in the Arduino. Let us first start with ASCII. Well, we have learned that our Arduino or digital device in general can only represent two values, high and low, or 1 and 0. But if we want our digital device to represent complex data such as characters, numbers, or punctuations, well, the obvious solution is that we need more than one bit. But how will we use combination of bits to represent these characters, numbers, and punctuations? Well, actually we can use any combination. Just have to make sure that both ends of the communication devices use the same representation. This way, we have to rely on some standard. The most commonly used standard that we will mention today is the ASCII standard. ASCII is the American Standard Code for Information Interchange. Basically, it tells us if we want to represent something like the letter A, what bits or what combination of bits should we use? Let me give you a more specific example. Well, assume that you want to display the letter 0, the character 0. Well, the ASCII standard say we have to use 8 bits to represent 0. They are 0, 0, 1, 1, 0, 0, 0, 0. But rather than writing long length of binary number, most of the time we use hexadecimal number to represent this sequence of binary. For example, if we divide the binary by 4, we will see that each 4 bit can represent one letter in hexadecimal number. So 0011 is actually number 3. Thus we use 3 to represent the first 4 bits, and we use 0 to represent the last 4 bits. Or you can also use decimal to represent our binary. In this case, the decimal number of letter 0 in ASCII code is number 48. Let's see another example. Say you want to encode character A, the capital A. Well, for the 8-bit combination of the character A is 0100 and 0001. Similar, we can use hexadecimal number 41 to represent our sequence of bits. When we write down to avoid confusion, we always have 0x in front of the hexadecimal number, so we know that we are talking about hex, not a decimal number. Right? And for the letter A, the decimal number is 65. Alright, let's move on to the next topics. Serial communication. Well, to ease understanding the serial communication, we have to first understand how will we transmit or sending data from one system to another. Now we know that the ASCII values use 8 bits to represent a character. So what if you want to send a letter A from one machine to another? How many wires do we need? Well, since we have 8 bits, That means we may need 8 wires for sending, another 8 wires for receiving. Put them all together, we may need one more wire for ground. Totally, we need 17 lines. Well, that's a lot. And if we want to make a long distance communication, 17 lines is kind of trouble to drag it from one end to another. But wait, what if we use just one line, one for sending and one for receiving, though we also need another one for ground. That means we can do all the communication with just 3 lines. This is good for long distance communication because we don't have trouble wiring that so many lines between the devices. But how can we send 8-bit data with just one line? Let me explain. Well, if both devices config for the same clock rate or baud rate. Now, let's say your computer wants to send a letter A to your Arduino board. Well, for a certain period of time, we just keep pumping data into the line. Let's say the first period we pump the first bit, then we pump the second bit, and so on. Once we're done with the 8-bit, the data commute to another end. Now, the other end just have to count for a certain period of time and lead each bit up one by one. Once we got all the 8-bit, we can recognize a characters. That means to use serial communication, both devices have to be configured for the same rate and same data format, or in this case we call a protocol. In this example, we just transmit a character A from your laptop to the Arduino board through the serial line communication. Luckily, you don't have to do that counting on the period by yourself because our Arduino has provided tools and library where you can just make a function call to set the baud rate and use the read or write function to send or receive data. Well, a little note here. If you want to read a data, make sure that you check for the serial variable functions. If the result is more than 0, means we have data waiting, or else you will read nothing from the serial line. Now, if you want to send data from your Arduino board to the host PC, well, you can use the write function. The write function always sends a byte of data. Arduino has also provided the print and print line function that will help you transmit several kinds of data. For example, you can just use print and followed by a string to send a string to the host. Or you can use serial.print or print line with any variables. By default, Arduino assumes that you want to print the data in decimal number. But if you want to print in hex number or bin or octal number, you just have to specify the format. I have just introduced you to the basics and the ideas of this lab. Let's see the demonstration. Maybe you understand more. What do I expect from you? In today's lab, you're gonna need this 7 segment, your Arduino board, connect the 7 segment to your Arduino board, and the push button switch. Connect this one to digital port number 8 to 13. For exercise number 1, you can just copy the code from the lab sheet into your sketch. Well, since I already have my sketch prepared, I can just open my sketch and load it. Here. In this exercise, basically I just set the serial communication and then make sure that the pin number 8 is set up for input bit pull up. So I just leave the input from the push button and show this logic out. Well, if you got it right, when you download it to your Arduino board, you should expect to see the logic show on the screen. To open the serial console, you just have to click this icon to show the serial monitors. By default, the serial monitors is set up for the baud rate 9600, so you don't have to do anything. You may also observe the first line of your serial monitors that allow you to type and send data to your Arduino board. But for the first exercise, we don't need this. Well, when you press your button, the logic gonna change from high to low, like this. Alright, this is the first exercise. Let's move on to the second exercise. In the exercise number 2, well, you just have to modify the code from the first exercise to detect a click from the button. I assume that you all knows how to detect a click, okay? But the results that I also expect to see a counter. So I declare a global variable for counter. And then I add the code to detect a click, like this. If there is a click, this is what I want to do. Print the click. However, we have seen from our lab for several times that a clicks mean press and release. So I wait until the button is released. Here we go. Alright, and let's see how it works. Alright, now if you got it right, this is what happens when you click the button. Keep on counting several times like this. But it's not that difficult. So basically you can just copy the code from the sketch that I provided for you and put it in your project, your sketch. Alright, so in this code, basically I just print the ASCII converter exercise number 3. Then in the main loop, I check if there is a data for us. If there are data for us, then I read. Once read, I output with the decimal number, hexadecimal number, and binary number. But please note that the code that I provided for you in the sheet is not complete, so you may want to make sure that you may want to do some modification. So you may want to do some modification to make it work properly as I expect. All right. This is what happens when you got it right. See, when I press number 1, you should see the number 1, the decimal value, the hexadecimal values, and the binary values of number 1. Try that with other characters. Well, you need this sketch to answer the question number 8. Here is exercise number 4. Well, for exercise number 4, you can just put code that I have provided from the previous lab for you. If you have the file handy, you can just import the sketch by use add file from the sketch menu. But anyway, you can just copy it from the sheet and type it down in another tab. Right? Now for the first tab, I just do this, write the output, okay, and then I read from the serial. If there is a data variable, I read the data. Now I just want to display the number. So we have learned from exercise number 3 that number, the ASCII value number is 0x30, that's for number 0. And for number 9, it is 0x39. So anything in between is just number 1, 2, 3, 4, 5, 6, 7, 8, right? So I make sure that I read the number and ignore the others. When I got the number, I just want the pure number, not the ASCII value. So I just substitute that value with 0x30 to get the real values. Then I use the display num routine from the previous lab and print it out to the serial console. Else, for others, I display the dash, so I create an array to show the dash and send that to the 7th segment. Then at the end of my program, I display the prompt again. This is what happens if you got it right. Well, when you type number like number 2, you will see number 2 at your 7th segment display. But when you type something else like letter A, you should see a dash at the 7th segment display. This is what happened when I type the dash, and this is what happened when I type number like number 9 or number 4. How is it? Not that difficult, right? Now we have come to the last exercise. Guess what? I will leave it to you to finish the last exercise. The code, the sketch that I have already provided for you is halfway done. So just think about it. You just have to use knowledge from the previous lab to finish this sketch and make it work. Anyway, enjoy and have fun. Until then, see you next week. Goodbye.